Hello and welcome back to the lecture series on statistics for machine learning. This is Amit Kumar Das, and we are going through we have already gone through the different concepts of descriptive statistics in the last few sessions. Now, before we get into the basics of inferential statistics, I think we need to understand the basics of a concept which basically provides the foundations of inferential statistics. That concept is the concept of probability, right? So before we move into inferential statistics, let's try to understand the concepts of probability. Now, when we talk about probability, I mean, again, in a very layman's term, just from a common English text perspective, uh, probability means, I mean, when we say that probably something is going to happen, that means there is a chance, right? There is a chance that something is going to happen. So basically, the term probability is a direct reflection of chance of occurrence of something, some event, right? And how, I mean, from where does the chance occurs? So the chance occurs from something which is called an experiment. So one is chance of a particular event occurring. So that is one. And how does the event occur? Event occurs as a part of a set of random experiments, right? So obviously it makes great sense to understand these terms, event and experiments, or rather random experiments. What does these two terms mean, right? So first, let's talk about experiments or random experiments. So experiments in the first place. So what is an experiment in context of probability? So an experiment basically is used to describe a particular action which can be repeated under certain given conditions. Okay, so what do I mean by certain given conditions? Let me take an example. Say, for example, I toss a coin. Okay, so I can keep on tossing a coin and I can note the outcome of that action, right? So if I toss a coin is like this, right? Either I can get a head or I can get a tail. So basically the action of tossing the coin is my experiment, right? Same way, the very common example which is generally given in context of probability is rolling of a die. So die is like a cuboid like this, right? So you can roll a die, and there are certain points which are there in the face of a coin, like one, then there is two, right? So there are different points on the different faces, and when you roll the die, the face which comes at the top, whatever is the point that you earn, right? So again, when you roll the die, that's the action you are taking. So basically, you keep on rolling die for once, twice, thrice, four times. So those are the experiments you conduct. And just note one point here. Whenever you're tossing a coin, given that it's an unbiased coin, right? There is no preference for having a head or a tail. Or when you are rolling a die, again, assuming that it's a unbiased die. So you can't say what outcome is going to come. Whether tossing the coin, will get a head or a tail, right? Same by rolling a die, you don't know whether you're going to get a one or a two or a three or a four or a five, right? So you don't know for sure which one you're going to get. So it's completely driven by a chance, right? So these kind of actions where you don't know what is going to be the outcome of the experiment. Okay, so outcome of the experiment is completely a chance factor. It doesn't, I mean, you can't say beforehand. Okay, is chance based, right? So that kind of an experiment is known as random experiment. So now you understand there are two things: random experiment, right, which is basically you're tossing a coin, you're rolling a die. Same, you can talk about the card and many other things, right? So multiple things. Then there is an outcome to that experiment. Each occurrence, whatever is the outcome, you can take that as the outcome of that experiment, and there are series of experiments you may have. And there is the third term which is still left out, event. Now, what is an event? You need to understand that that is another very important concept in context of probability. So event is nothing but a combination of one or more outcomes. Okay, so say for example, let me take a very crude example again. So when I roll a die, so each of these things like having a 1 or having a 2, okay, all these are possible outcomes, right? Now, if you just think about each of these outcomes as one event, that is called an elementary event. Also, what you can do is you can combine more such outcomes and make an event. Say, for example, you can define an event E as the point which is being shown is uh, even. Point is even. Okay, so this is definitely an or even you can have a odd, the point being odd, so this is an even. So what will be the, I mean, if I just consider from a set theoretic perspective, what will be the thing if we consider the point as the event? So 2, then sorry, so I can have a 2, I can have a 2, I can have a 4, I can have a 6. So, and if I consider the event, so this is say E1, and if I consider other events, say E2, okay, and that being the point is odd. Okay, so what will be the set which is reflecting, which is going to kind of represent this event? So 1, then 3, then 5. I can also define an event like say multiple of 3, right? So in that case again it will be an elementary event. So only 3, no, there are two elements, so 3 and 6, right? So like this, we can see that there are three important concepts, the basic concepts on which probability, the concept of probability is standing on. One is the random experiment. So that is the first thing, which is what? Which is basically a set of actions which can be repeated under some given conditions, and the outcome of which is completely driven by chance. You cannot say what is going to be the outcome right before the experiment happens. Okay, so that result is unknown. Then what? Then is the outcome. What is the outcome? When you are doing an experiment, when you are taking a particular action like tossing a coin, the result of conducting that experiment is called the outcome. And what is an event? What should I say? A combination of multiple outcomes, right? Say, for example, when I say that for the rolling of a die, the point which is being coming in, which is coming in the going to come in the upper surface, the point is a odd point. Okay, so that case, what will be the set representing that? 1, 3, 5, like this. Okay, so multiple events or maybe multiple outcomes or single outcome can constitute an event. If the event cannot be broken down into portions, then it's called an elementary event. And if it can be decomposed or broken down into multiple smaller events, then it is called a composite event, right? So this is where I think we can start off. Next, when we come back, we are going to talk about some more about events, the different types of events, and then we also will touch how the probability of a particular random experiment can be calculated, right? So stay tuned. Thank you very much.